Okay, so for today's deep dive, we are tackling a very specific and I think universal headache in the AV world,
Oh, yeah.
the USB-C distance limit.
Right. It's fundamentally a physics problem.
It is. You know, the drill USB-C is amazing for speed, for power, but physics just keeps it on this really short leash.
A very short leash. You get, what, 2 or 3 meters maybe? And then the signal just starts to degrade.
Or just drops out completely.
Exactly. Those high-frequency signals for, 4K video or fast data, they just die off so quickly over standard copper.
Which is why wiring a modern conference room can be, well, a nightmare. But we're looking at a piece of hardware today that claims to just break that rule.
It does.
We're digging into the Kramer CLS-AOCU32-FF-35. It's the USBC cable that runs for 35 feet. That's nearly 11 meters.
Which should be impossible.
Right. So the mission is to figure out how. Is this just like super thick shielding, or is there something else going on under the hood?
Oh, it is definitely something else. I mean, if you were to cut this thing open, you wouldn't just find copper. This is what's known as an active AOC hybrid cable.
AOC, active optical cable. So we're talking fiber optics.
Precisely. It's hybrid engineering. It uses these tiny fiber optic strands for all the high bandwidth stuff.
So the video signal, the big data transfers?
Yep. Fiber uses light, not electricity, so it's basically immune to the interference and resistance that kills the signal in a long copper wire.
But wait, fiber can't carry power. Yeah, that's a huge deal for USB-C. You need to charge the laptop you're presenting from.
And that's the hybrid part. Running right alongside those glass fibers are actual copper wires.
I know. Okay.
But they're dedicated pretty much just to power delivery and some of the, lower speed control signals.
So you get the speed and distance of fiber, but you still get the utility of copper.
You get both. Best of both worlds.
Let's get into the specs from the source material, because working at 35 feet is one thing, but, what's the actual performance like?
Well, the specs are basically maxed out for this USB generation. It's pushing 4K video at 60 frames per second.
With 4.4.4 color, I saw.
Yes, and that is so crucial.
For anyone who isn't a video engineer, that 4.4.4 means zero color compression.
Right. No chroma subsampling. What you send is exactly what you see, pixel for pixel.
Which is why text doesn't get all blurry like it can with long, cheap cables that have to compress the signal.
Exactly. It's pretty much lossless. And then on the data side, it pushes 10 gigabits per second.
So full USB 3.2 Gen 2 speed.
All the way. And for power, those copper lines we talked about, they can deliver up to 100 watts.
Wow. That's significant. That's enough to fast charge a MacBook Pro while it's driving that 4K display from across the room.
Correct. And we have to talk about the active part of its name. There are tiny microchips inside the connector heads themselves.
So it's not just a passive wire.
Not at all. It's a transceiver. It's converting electricity to light on one end and then light back to electricity on the other instantly.
Okay, I want to pivot a bit to the physical side. One of the sources mentioned something called the K-lock. As someone who's seen a presentation die because a cable got wiggled loose, this really caught my eye.
It's a huge pain point.
Yeah.
The standard USB-C connector just isn't designed for a secure professional install. It's fine for your phone.
Right.
The K-lock is this internal retention mechanism they built in. It gives you about 15 pounds of pull resistance.
So it's like a really tight friction fit.
Essentially, yeah. It just stops that little bit of wobble that can cause the signal to drop. If you're running this cable through a wall or a ceiling, that reliability it's non-negotiable.
Speaking of running it through walls, the spec sheet had these acronyms, LSHF and CPRDK.
Yeah, you're not going to find those on your average charging cable.
Right.
These are building safety standards. LSHF is low smoke, halogen free. It means if there's a fire, the cable jacket won't release all this toxic black smoke and acid gas like normal PVC does.
So it's designed from the ground up for permanent infrastructure.
It is.
And with all this tech packed in, the fiber, the active chips, the safety ratings, do you need special drivers to run it?
No, and that's the beautiful part. It's completely plug and play.
Really?
Yeah. Windows, Mac, mobile, your device just sees it as a normal passive cable. No software needed.
Which brings us to the elephant in the room.
The price.
The price. We're seeing it for around $396.
Yeah, and that's a discount from like almost $500. It's sticker shock if you think of it as just a cable.
It is.
But you have to think about the alternative. To do this same job, you'd usually need a transmitter box, a receiver box, separate power supplies for both.
Right. You're basically paying to replace 3 or 4 different pieces of hardware.
Exactly. This just simplifies the entire architecture. You plug it in, and that whole physics problem, it just goes away.
So it's a shift in how you think about it. The cable isn't the accessory anymore.
The cable is the infrastructure.
It becomes the strongest link in the chain, not the weakest.
That's the key takeaway right there.
A really fascinating look at what it takes just to move some data across a room. So here's a thought to leave you with. With tech like this, we're seeing fiber optics finally reach all the way to the desktop. As our bandwidth needs just continue to explode, how long is it before the copper wire just disappears from that last connection entirely? Thanks for listening to The Deep Dive.